everyone, it's Norm from Tested. And first of all, happy holidays. Although I guess depending on when you're watching this, maybe happy new year. As I'm recording this, we are wrapping up 2021, which has been a pretty exciting year for people who are interested in resin printing and resin printing enthusiasts, or 3D modelers, people interested in tabletop gaming, people using resin printing for cosplay props. It's just become that much more accessible. And there've been a ton of printer options out there. Today, I'm reviewing the Phrozen Sonic Mini 8K. It's a highly anticipated mSLA 3D printer from Phrozen. They were able to get me a unit to test for the past couple weeks, and it is a very interesting 3D printer. 8K, what does that mean? There's so much to talk about, but from a broad sense, let's give an overview of where we are today in mSLA printers. Because at the end of last year, we saw a big technology jump in terms of what was available, in terms of the size of the things you can print, the quality of those prints, in terms of the panels that those manufacturers were using as their masking layer, and also the type of panels. So much faster prints as manufacturers move to mono LCDs. And as a quick overview again, these are resin printers. So it's basically turning a 3D model that you slice into many layers. And then there's a vat of liquid resin in here. That's the vat right there. And layer by layer, this build plate rises and the resin is cured from a UV light that's underneath on the bottom here. So UV light, whether that's from an array of UV LEDs, lensing, or maybe now COB LED strips of the UV variety, they blast UV light through a masking layer. So that's an LCD typically. LCD panel, which at every layer, it blots out what should not be cured and only what should be cured. And then layer by layer, they're turning that masked cured layer into a 3D object. Manufacturers, from Phrozen, from Elegoo, from Anycubic, making printers that are all frankly really similar in terms of the user experience. And in fact, they share a lot of not just design elements, but also components as well. We're talking about all using very similar rail systems, stepper motors for the Z-axis, milled aluminum build plates, and also control board, many of them using from CTB systems. If you're using a printer that uses the choo-choo box as the primary slicer, chances are, it uses that CTB systems control board. And so, and they all have like that touchscreen interface, all transfer files over a USB key. And so the differences may be in terms of the build quality, the vat size, and most importantly, the build plate size, the build volume, which is correlated with that LCD panel. And so when you see, a company touting, here an 8K resolution printer versus a 4K, or you may see a 6K, that actually by itself is not very meaningful, because when you even like when you're shopping for a TV, you might see 4K TV, or in the future an 8K TV. What matters is the pixel resolution, how many pixels wide by how many pixels tall, correlated with the actual size, right? The size of that panel, the size of that TV, like in terms of VR headsets, the FOV, field of view of that VR headset. A lot of these things, a lot of similar parallels there. And when Phrozen has put an 8K panel here, which is incredible, like 4K only became like the standard toward the end of last year, beginning of this year. What they're also touting is the pixel size. And it's not labeled here, but the size of the individual pixels per layer is 22 microns. So 0.022 millimeters, which is much smaller than what your standard maybe layer height might be. A sweet spot for layer height is 50 microns, although you can print as small as like 10 microns on some of these printers. And I have something to illustrate here in terms of the build size, the build plate size. I didn't want to take this out. So I laser cut a bunch of examples of what the build size, not necessarily the volume, but the X and Y axis, the build plate looks like on these printers. And here's well, let me show you the Sonic Mini 4K first. So this is the build size, the plate size of Phrozen's earlier 4K mini printer. And in terms of printers, you can think of them as there's like small, medium, and large. Small is really great for tabletop miniatures. Medium, like you get with like the Elegoo Saturn or the Anycubic Mono X. That's usable for maybe props and miniatures as well, but props, but not maybe helmets. And then you have like the large size, the XL size. So Peoples, their Phenom XL, the Anycubic or the Elegoo, the Jupiter that's coming out soon. I'd consider those the largest size consumer resin printers. But really, in terms of the small size, I don't want to say entry level because some of those can be quite expensive as well. The Mini 4K had a build plate about this size. And the 8K here, interestingly, because of the LCD they sourced, has a much wider build plate. Also not as deep. So the y-axis is reduced just a little bit, has a much wider x-axis here, which means that you can maybe print more things on the Sonic Mini 8K, stack more miniatures on the plate at once, print wider things, but not necessarily larger overall things. If you have a large model like a dragon, for example, with a big curled up tail, you couldn't fit that on the Mini 8K at the max width because it doesn't have the depth there. And because it's spreading those 8K pixels over a larger area than this 4K, it's not quite like half the pixel size. So at 35 microns of the Sonic Mini 4K, here 22 microns, so we're not yet at that 16, 17, 18 micron size, which seems unfathomable over about a year ago. And in comparison, the last printer I reviewed was the Elegoo Mars 3. So here's a size comparison. That's a 4K panel, but the aspect ratio is more square, still rectangular, but deeper. And that actually, I think, allows you to print larger objects. Like I said, if you have something, with a big curled up tail or something, or a robot that's more boxy than it is wide, you're going to be able to print that on the Mars 3, and it might not fit at that same scale on the bed of the Mini 8K, just because of the LCD panels in the supply chain that these manufacturers chose for their printers. And then if you go up to, I just printed these just for, laser cut these out for fun, the medium-sized printers. Here's an example. This is the bed size of the Elegoo Saturn, and that's at 50 microns pixel size, 4K panel, mono panel as well, and then more recently announced Anycubic's Mono X 6K, which is 35 microns. So 50 seemed like a good sweet spot for this past year. Definitely, that was the baseline for if you want to find a high quality resin printer. And then 35 microns at these 4K printers of the Mars 3 or the 6K one, like you're going to get more detail. And then of the 8K of the Phrozen Sonic Mini 8K, well, how much more detail is the question. And so I printed about a dozen things over the past 2 weeks, a mixture of models at 100% scaling. So from some of the Patreons I back for tabletop miniatures, in addition to scaling down some larger models that were maybe meant for a larger printer, but I wanted to see what it could be, if that detail could be resolved if I scaled it down 50% or so. So let's start with one of those. This is a model that I previously would have printed maybe at 5 inches tall or so, 14, 15 centimeters tall, but scaled down. I wanted to see if I could retain or what details I could make out on this 8K printer. And you know what? They're basically all there. When you're talking about the benefits of higher resolution, You're talking about seeing fewer layer lines. You're also looking at the kind of the surface texture. It's all geometry. So when I say texture, I really mean like surface detail. It's being sculpted. So in terms of the creature, the skin indents, any of the scales that might be on these lizard creatures, as well as structural complexity, additional geometry that might have been put into the hard parts, the backpack here or the blaster here. Could that be resolved at the smaller size? And it looks fantastic. I mean, you'll see up in these close-ups, the skin detail is all there. And I can barely notice, I don't think I can even see the layer lines. This was printed at 35 microns per layer. So yes, very impressed, but that's in a vacuum, and that really doesn't mean anything if you're talking about a 22 micron pixel size versus a 35 micron pixel size. So let's look at some comparisons. Here are two characters printed at 100% scaling. This is from Lord of the Print, and again, a mixture of some surface detail complexity in the skin of this dinosaur, as well as some geometric complexity on this backpack it's carrying. And you know what? According, to my naked eye, I am really, really hard pressed to spot the differences. I mean, I showed this to my family. I've stared at these for minutes, and I'm trying to see if there are details on the Phrozen Mini 8K print that I can't see on the Mars 3 print. And I don't think there are any. I mean, even layer line wise, I don't see layer lines on the Mars 3. They look almost exactly the same at an object of this size. Even going to comparing some of the models that Phrozen included on their USB key, models that were meant to demonstrate, the fidelity of the prints here, they look almost exactly the same to my eye as the prints coming out of the Mars 3. So I did take some models and I scaled them down to really small size to really push the print detail to the limits. Here's an example, also from Lord of the Print. This is another dinosaur that's carrying, a whole kind of encampment on its back, as well as with a tiny figure mounted on the top. And I mean, it blows me away. Just the skin surface detail on this dinosaur to the hat on this figure. It's like, I can't believe that this came out of a printer. But if you look at the back, this is not supposed to be as destroyed as this model is. And that's because something I realize is the smaller I started to scale these models for the printer, the harder it became to salvage or to retain those details without damaging the model because of the support structures. I mean, you're going to have to scale the supports down, and at some point, because of the physics of the resin and the weight of the printer and the lift forces, you're going to need supports of a certain touch point diameter. So even taking down my support so they're easy to tear off, I was still damaging the models because these models became so fragile, because even curing this at 2 seconds per layer, and it feels sturdy, the supports were tearing the models apart at just how small they were. So that's just something to consider when you're printing something and you're trying to shrink it further down and further down. Yes, it's possible, and it's possible to keep that detail, but at some point your support's going to overwhelm and they're going to destroy the model when you try to snip them off or tear them off. Here's another example of a character that I want to print to take advantage of that resolution, and I looked at wings, so feathers here. Again, a lot of surface detail, also a lot of overlapping geometry, which can be taxing for a printer, and this printed out perfectly. I mean, see just the overlapping layers of the wings, even the tiny, the pinpoint sharpness of the horns of the helmet here. This was truly, truly impressive coming out of the 8K printer. Another print here though with wings, this also lots of feathers, lots of overlapping details, and also miniature character here. The wings ended up snapping off just because, again, once you get to a point where the scale of the model is so small, the supports, tearing off the supports ended up damaging the model here. And I did have a couple of print failures. With the print, you'll see in the time lapse, one of my time lapses, the raft that I printed detached from the back right side. And so I did some releveling of the z-axis. I went and sanded down the build plate to give a little more gription, as well to make sure it was perfectly level. And I bumped up the exposure time on my bottom layers up to even 60 seconds. And I still had, in another instance, a detaching raft. So not sure if that's just because of the print settings or the resin I'm using, or if it's because of the build plate. I didn't notice any wobbliness on the z-axis, but that was something that I wasn't able to fully solve yet. Something I'll be looking forward to is getting a Wham Bam magnetic build plate attached to this, and I've had really great success with those, and it'll be interesting to see the prints coming out once that arrives. But at the end of the day, the 8K prints, yes, were impressive, but were they noticeably impressive to my eye compared to a print out of like the Mars 3, a 35 micron print? I can't say that it was night and day of a difference. I think, if you are forcing yourself to look for it, I think, yes, the 8K prints, I think, are a little bit better. And something also to consider is that over time, if you're going to be using and printing a lot, the FEP film on the bottom of the vat will get cloudy over time, and that might take away any benefits of having a high resolution screen, because the cloudiness is just going to obscure that detail. So you might need to replace that FEP film more frequently than you would a different printer. And in terms of print quality, I'm going to let the video and images of my test print speak for themselves. And to my eyes, I was really hard pressed to notice dramatic improvements between a 35 micron print and a 22 micron print. And so it really may come down to the bed size, going back again to the size of the LCD, the aspect ratio, and the size of the build plate, because it really is a unique situation here with this wide aspect ratio build plate. And like I said, if you're printing, a character like this, where if you look at the top down, the wings are wide, it doesn't need a lot of depth. You care about just how wide this character is. Yeah, that's going to be nice on this print bed. Or if you want to, do a lot of gang printing and print a bunch of minis all at once, that also makes sense. If you want to print something larger, though, I think you're going to be limited by this depth here, because if you look at the Mars 3, I actually like the larger size objects. If you have you're printing a dragon or something with a tail that coils around, something a little more circular and isn't as flat, I'm going to want that Y depth here and not necessarily need as wide of a x-axis. So at the end of the day, the Phrozen Sonic Mini 8K, where does that stand, and what does that mean for resin printers maybe going forward? Well, first of all, it tells me that manufacturers have been able to find 8K panels at an affordable price in the supply chain to start incorporating and designing 3D printers based on that resolution. I'm still not a big fan of this aspect ratio, and so in my dream scenario, in the dream world, I would actually would love to have a high resolution panel with a more square, maybe 4:3 aspect ratio build plate, something closer to that of the Mars 3. And there was a big price difference as well. I think Phrozen did bump up the price and level up the build quality of this printer. So it's really rock solid with dual rails. Most of this is aluminum, not a ton of plastic parts. It has a large footprint actually for a printer, but also still relatively quiet in operation. And so it does feel like more of a premium mSLA printer of this size. Definitely, I would not consider this an entry-level printer if you're just getting started into resin printing. If you're looking for your first resin printer and you're into printing tabletop miniatures, I'd still consider something smaller, maybe like the Sonic Mini 4K or the Elegoo Mars 3. And I can recommend both of those now and this printer now because CTB Systems has worked with Mango to make sure that the Lychee slicer can actually, with its latest version, I believe 3.6 and newer, generate slice files that work with these printers and adopt some of the functionality like the TSMC, like the two-tier motion control, two-step motion control. So a different lift speed, removing from the FEP film versus separating, getting out of the vat. So you can even do much faster prints using that dual speed lift. If you're looking to spend $500 on a 3D printer, this is $600 MSRP, $500 introductory special pricing. You're kind of choosing between high resolution, small pixel size printer like this or a larger bed, something like the Elegoo Saturn or the Mono X 6K. And I think you might get more benefit out of a larger bed printer than you would out of a higher resolution printer, just in a broad sense. 50 microns pixel size feels like kind of the bare minimum, the baseline for resin printing going forward. I wouldn't want to get a resin printer of a medium size or small size with anything less than a 50 micron or anything larger than a 50 micron pixel size. I think 35 microns might become sort of the baseline for 2022, and 22 microns, well, I think we are reaching the point of diminishing returns, which isn't to say the benefits aren't there, but to my eyes, to my maybe untrained eyes in terms of miniatures, I certainly find it hard-pressed to find the differences, to see the difference between a 22 micron print and a 35 micron pixel size print. They look so similar. You won't be disappointed with either of those. So hopefully that gives you a sense of what the landscape is in terms of mSLA printers. I'll be continuing to do more prints on this, incorporating it into my workflow alongside my other printers. So if you have questions about the Phrozen Sonic Mini 8K, please post them in the comments below. But thanks again for watching, and I will see you next time. Bye-bye.